If you want to stop a rogue robot, just run behind it and pull the batteries out. Okay, let's just pause right there because I absolutely love this quote. It perfectly captures exactly where we are in the world of robotics right now. On one hand, you have these viral, honestly kind of intimidating videos of Boston Dynamics robots doing backflips and parkour. But then on the other hand, you have this highly practical, incredibly grounded engineering where the ultimate high-tech failsafe is literally just yanking a battery pack out of its back. So today, we are going way beyond that viral hype.
Welcome to today's Explainer. Our core goal today is pretty straightforward. We're going to demystify the massive technological and business shifts that are taking humanoid robots from being, fun little YouTube novelties to serious mass-produced industrial tools. We'll be focusing heavily on the brand new fully electric Atlas robot by Boston Dynamics, but we'll also zoom out and see exactly how it fits into what is quickly becoming a massive global industry.
Here's our roadmap for the Explainer. First, we'll meet the new Atlas. Second, we'll explore moving beyond human limits. Third, we'll dive into the AI intelligence layer. Fourth, we'll discuss entering the real workforce. And finally, number 5, we'll look at the global humanoid race.
All right, kicking things off with Section 1. Meet the new Atlas, Anatomy of a New Worker.
So this really begs a fundamental question we had to ask right out of the gate. Why build a human-shaped robot at all? If your main goal as an engineer is purely efficiency, why obsess over building a wobbly, bipedal robot with 2 legs instead of just slapping some tracks or wheels on it and making it incredibly stable?
Well, the answer from the engineers is surprisingly simple. We built our world for humans. Think about it for a second. Our factory floors, our stairs, our doors, those super tight corners and warehouses, every single environment we operate in was designed entirely around the human form factor. So if you want a machine to just drop into an existing facility without having to spend tens of millions of dollars remodeling the whole place, the most effective way to automate tasks is to just match the human shape. Legs give you access to our world. And when we start comparing the actual physical sizes of these human shapes, a super fascinating contrast emerges. You've got NASA's Valkyrie towering over things at 6'2". Tesla's Optimus is around 5'8". But the new Atlas? It is intentionally built at just 4'11". That is roughly the height of an average 12-year-old. The source material points out this is highly intentional. A smaller, more compact robot is just naturally more approachable. It's way less intimidating. The ultimate goal here is to build a helpful tool, not a towering, scary giant.
Moving right along to Section 2, Moving Beyond Human Limits, Hypermobility and Psychology.
Boston Dynamics loves to say that Atlas is inspired by the human form, but definitely not limited by it. And this is where the hardware engineering gets absolutely brilliant. They have completely eliminated all the external cables running across the joints. And because there are no cables to get tangled up or snap under pressure, Atlas has infinite 360-degree joint rotation. Its torso, its arms, its legs, they can all just spin completely around. This allows the robot to move in highly efficient, albeit kind of alien-looking ways. Like, instead of awkwardly shuffling its feet to turn around, it can just rotate its torso backwards and immediately start walking the other way. But getting that physical body to move naturally brings us to a really fascinating concept called Moravec's paradox. This is a core robotics principle that says high-level reasoning, think playing chess or an AI generating text, actually requires very little computation in the grand scheme of things. But low-level sensoromotor skills like simply walking, keeping balance, or grabbing an irregular object, those are unbelievably hard to replicate. This paradox is exactly why Atlas can execute a perfect explosive backflip for a viral video, but it's still going to struggle with what we would consider a super simple task, like just sitting down in a normal office chair. Essentially, the easy things for humans are actually the hardest things for robots. And yet, because they move like us, they kind of trick our brains. In one of our sources, YouTuber Cleo Abram actually visited the lab, and the engineers invited her to violently shove Atlas right in the chest just to test its balance. And she reported feeling genuine guilt. She immediately apologized to the robot. This brilliantly illustrates a huge psychological factor at play here. We inherently project human empathy onto human-shaped machines. As these things enter the workforce, society is going to face a massive learning curve in treating them as the tools they actually are, rather than the living peers they happen to resemble. Okay, on to Section 3, the AI intelligence layer, brains, balance, and simulation. Let's actually walk through how Atlas learns a complex physical task.
Take a recent test where it had to lift this bulky, constantly shifting 100-pound mini fridge. It doesn't just use its cameras, it uses proprioception, which is an internal body awareness of weight, balance, and grip. So, step 1 is the reference trajectory, basically setting a basic goal or animation. Step 2 is reinforcement learning in simulation. The robot practices doing it millions of times in a perfect virtual world. Step 3 is domain randomization. This is where engineers add total chaos, tweaking the fridge's weight randomly or making the virtual floors super slippery. Finally, step 4 is the real-world hardware test. It takes all that chaotic virtual training and adapts its physical body on the fly, exactly like a human naturally leaning into a heavy object. But transferring from that virtual chaos in step 3 to the physical hardware in step 4, that is known as the sim-to-real gap, and it is easily the hardest part of robotics. This is the big difference between how perfectly a robot behaves in a pristine computer simulation versus how it actually performs in the messy, completely unpredictable physical world. Closing this sim-to-real gap is literally the holy grail for companies like Boston Dynamics right now. So what actually causes this gap? Well, in the real world, you are fighting latency in the wiring. You have physical vibrations shaking the frame. There's sensor noise, dirty floors with uneven friction, and even tiny, microscopic manufacturing differences in the motors themselves. The real world is just messy. The brilliant countermeasure they use in the new electric Atlas is simplified, repeated hardware. Both arms are identical to each other. Both legs are identical. By simplifying the physical machine, they make the digital simulation way more accurate, which dramatically shrinks that sim-to-real gap. Which brings us to Section 4, entering the real workforce, the mass-scale plan. 30,000. I really want you to just take a second to digest this number, because this isn't some arbitrary benchmark for software users. This is physical manufacturing. Boston Dynamics' parent company, Hyundai Motor Group, is currently building a dedicated robotics factory with the goal of an annual production capacity of 30,000 Atlas robots. This absolutely proves that we are moving way, way beyond just having a couple of cool test units sitting in the corner of a university lab somewhere. If we trace out the timeline for the next few years, you can see how fast this is moving. In 2026, the current supply is completely allocated internally to Hyundai and their AI partners for rigorous testing. By 2028, the global rollout officially begins, heavily focused at Hyundai's massive Metaplant America down in Georgia. And by 2030, these robots are slated to move from doing simple material handling to actually performing complex, high-precision automotive assembly tasks right on the line. This is a very real and very imminent industrial rollout. And here is the specific software feature that makes mass deployment like that viable: fleet learning, which runs through Boston Dynamics' Orbit platform. When one single Atlas robot figures out the absolute optimal way to lift an awkward car part, that knowledge doesn't just stay isolated to that one machine, it is instantly transferred to every other unit in the entire fleet. So if a factory decides to change its product line overnight, managers can literally flash and reprogram an entire workforce of robots by the very next morning. It is a total game changer. And finally, Section 5, the global humanoid race, competitions, and coexistence. Now, looking across the globe, the approaches to AI training are wildly diverse. Tesla, for instance, is leaning super heavily on the massive neural networks and all that real-world visual data they've already built up for their self-driving cars, translating vehicle autonomy directly into humanoid autonomy. On the flip side, you have China's unit tree testing its G1 robot using live voice-driven action generation. So instead of just writing code for it, an operator can speak a command out loud, and the AI literally generates the physical movement sequence for the robot in real time so it can maintain its balance and execute the task. And the business models are fragmenting in really fascinating ways too. Heavyweights like Tesla and Boston Dynamics are squarely focused on selling the hardware, building physical multi-million-dollar robotic fleets for heavy industry and automotive plants. But then you look at a company like Gatsby, and they're taking a totally different route. They're selling the service. Using an Uber-style model, they charge a flat $150 fee to have an autonomous humanoid robot come and clean a consumer's apartment in San Francisco. You don't buy the $20,000 robot, you just book the labor. They are totally hardware agnostic, simply providing that consumer service layer. But across all these wild differences and competitors, there really is a unified philosophy trying to ease the public's completely understandable anxiety. Hyundai beautifully summarized their overarching goal like this: they don't compete with humans, they compete for humans. The ultimate vision here is that these machines aren't replacements, they are advanced tools, built to elevate human safety, take over the dull and dangerous work, and drastically increase efficiency by acting as collaborative colleagues right on the factory floor. Which really leaves us with one final, incredibly personal question to wrap up today's explainer.
The tech is advancing way faster than anyone predicted. Mass production facilities are being built right now as we speak. So, when humanoid robots inevitably become a common, everyday reality, where will you personally see them first? Will it be isolated away in factories, maybe managing logistics in big warehouses? Or will it be putting away groceries in your own home? Let that sink in. Thanks for exploring this with us today, and keep learning.